Okay, page 2, we'll switch back to pen so we can see it a little bit better here. Sketch the restricted function and state the domain and range. So again, we want to draw this function, but only for values of x that are greater than or equal to -2. So then -2 is where our boundary line is going to be. I'm going to go ahead and plot that so we can see which side of the graph we want. So I'm going to draw, I'll try to make it thick lines here, little dotted boundary line at x equals -2. If you want to make it a solid line, you can. It doesn't have to be dotted. It's just my habit. Okay, and then we want to draw this parabola, but only on the right side of that line where the x values are greater than or equal to -2. Okay, so how do we draw this parabola normally? Okay, so let's see. Our vertex for this parabola would be at -2, 2, because it's shifted from the origin over 2 and up 2. Okay, so it's going to be right here. Now, I always start with an open circle because you can always fill in an open circle. Do we want to actually include that point? Yeah, it says x is greater than or equal to -2, so then we do want to include this vertex here, so I'm going to make that a solid point. So, visualize a little bit. Normally this is going to be a U-shaped parabola, but we only want stuff on one half of that side of the parabola, so we're going to have, half of a U, half of a parabola. So we only got to worry about the right side here. All right, let's see. Our parabola is opening down, and our a value is 1, so I'm going to go over 1 and down 1. If I want another point, I can go over 2 and down 4. And then I don't need to worry about the left side there because we only want stuff on the right side of that line. And my parabola is going to be, well, half of a parabola going down like that. Okay. What is f of -2? When x is -2, well, y is +2. We can see that point right there. We don't need to plug it in, but we could. If I plug in -2, I get -2 plus 2 is 0. 0 squared is 0. The opposite of that is still 0. Plus 2 is 2. So you can plug it in, or you can just look at your graph. Okay? And then next, the domain. What's the domain for my function? Well, it's right there. So how do we write that in interval notation? This is saying x can be anything bigger than or equal to -2. So my values go from -2, including -2, to infinity. And always parentheses around infinity. Okay, and then what about my range? Well, for your range, just look at your graph. And remember, we always start with the smallest number. This thing goes down forever, so my range goes from -infinity up to the highest point of my graph, which is +2. And then, yeah, it's a filled-in circle, so we do want to include +2. Okay, so then there's the first one on the second page here. Okay, one more of this type. Let's scoot over a bit. Now we want to draw another parabola. In our domain restrictions, we want the parabola only between x values of -3 and +1. So this one, again, is going to have two boundary lines at -3. Try to make these lines thick so we can see them on the camera. And +1. So we only want a little skinny chunk of our parabola. Just everything between those two dotted lines. Zoom in a little bit, maybe. All right. Now, what would our parabola normally look like? Let's see. Our vertex would be at -1, -3, -1, -3. So that's good. It is in between our 2 points here, and then it's going to be opening up, and it's going to, hit those two lines somewhere. Now, how many more points do we need to draw our parabola? Do we just need the lattice points? Those would be helpful, but we really need to know exactly where our parabola is hitting this line and where it's hitting this line. So rather than get some random points like our lattice points, let's find out exactly where it hits those points. In other words, I want to know, I'm going to make a table here. What is my y value when x is +1? Because when x is +1, it's going to hit this line somewhere. What's my y value when x is -3? So we can just plug in those 2 points, and that way we'll know where it hits our graph. You can also use the pattern for your parabola. We go over 1, up 1 squared, over 2, up 2 squared. So it should be right here and right here. Okay, but let's plug in and make sure that we're correct, and we can always fill those circles in later. Okay, let's see, if I plug in x is 1, I plug it in here, so 1 plus 1 is 2. 2 squared is 4, minus 3 is 1. So we get the point 1 comma 1, and then yeah, that's where we thought it was using the pattern. If I stick in negative 3 plus 1 is negative 2. Negative 2 squared is positive 4, minus 3 is positive 1. So negative 3 comma 1, yeah, that's where we thought it was. Okay, so it doesn't matter how you get these 2 points, but we need to know where exactly does it hit these lines, because we need to know where to stop our parabola. And if you want to put the lattice points in there as well, over 1 up our a value, which is 1, you can do that too. And our parabola is going to look like that. So it's just a little bottom chunk of the parabola there. Okay. All right, let's see. We want x values greater than negative 3, so we're not including that point. We're going to leave that an open circle. And then less than or equal to positive 1, so we're going to fill in the circle. We do want to include that point. Okay, so what is f of negative 3? Well, that point doesn't exist. That's not part of our function. What's f of 1? When x is 1, y is 1. So then that one does have an answer of 1. All right, and the last part, what's the domain and range? Well, my domain goes from negative 3 to 1. Are we including negative 3? No. Are we including 1? Yes. So then parentheses here, brackets here. And then the range, well, my y values go from here to here. So from negative 3 up to positive 1. Just happens to be the same as the domain. The only difference is y can be negative 3, where x could not, and then y can also be 1 right there. So brackets around both of those. All right, and then there's the last graphing one. Okay, now the last 2 problems, here we want to write the equation for the graph shown, and we want to figure out what that function is and the domain restriction. Okay, so here we can see we've got an open circle here, and then the graph keeps going on. It's not really an arrow here, but there probably should be an arrow. That means that graph keeps going on forever. If there's no point there, we assume it's going on forever. So it looks like we want everything from x equals positive 1 and bigger. So then we already kind of know the domain restriction. X is going to be greater than positive 1. Okay, but then what's the equation of this graph going to be? Well, let's see. This is a U-shape, a parabola. So what's the equation of a parabola look like? Well, it's going to be in this form. Y equals some a value times x minus h squared plus k. All right, let's see if we can figure out the pieces of that graph. So it's going to be y equals our a value. And then what is our a value? Now, sometimes that's hard to figure out, but let's see. They went over 1 and then up 1, which means over 1 and up our a value. That means our a value is 1. So we can put a 1 here, or we can just leave it blank. Okay? We don't need to put the 1, but we can. I'll go ahead and put it in here. And then it's going to be x minus something squared, and then plus or minus something at the end. And then how was our graph shifted from the origin? Let's see, they went over 2 and up 1. So to move right 2, I've got to have x minus 2 in my equation. To move up 1, I've got to have plus 1 in my equation. So then now we've got our function. If we had the entire parabola, that would be our function. Okay, so then we can write that up here. F of x is like the y equals part for us. And we don't need to write the 1. We're just going to put x minus 2 squared plus 1. And then we don't want that entire function. We just want that function if what is true. Or like we said earlier, we only want the values of x greater than 1. So if x is greater than 1. Okay, and since it's an open circle, we don't put the line underneath because it's not greater than or equal to, it's just greater than. And then that's our answer. Okay, moving on to the last one. Now we want to find the equation of this absolute value function. Okay, and again, this is going forever in that direction. Okay, if there's no point like that one, it goes on forever. All right, so then what's our equation going to look like? Well, it's going to be y equals some a value times the absolute value of something with x in it, and plus or minus some other number. And then let's see if we can figure out what these 3 variables are. All right, so it's going to be y equals, and then what is our a value? Now remember, your a value is just your slope between this point and that point, or this point and that point. So what's the slope here? Let's see, I'm going to go from this one to that one because this isn't cut off at all. I'm going to go up 2 and over 1, 2, 3, 4. Up 2 over 4 is the same as up 1 over 2, up 1 over 2. Yeah, so it looks like 1 over 2 is my a value, which is my slope. And then times the absolute value of something with x in it, and plus or minus something else. So let's see, how is our graph shifted? Well, the x values, they went back 2 and then down 3. What do I have to have in my equation to shift left 2? It's got to be x plus 2. Okay, and then they also shifted down 3, which means we got to have a minus 3 at the end. Okay, so now we've got our whole equation, and then we'll figure out which part of that equation we want in just a second. Let's fill that in up here first. So our function is y equals, they already got that right here, 1/2 times the absolute value of x plus 2 minus 3. Okay, and then we want that function if what's true about x? Well, we only want the x values to the right of this point here. In other words, we want x to be bigger than what point? Well, this is the -1, 2, 3, 4. So x has to be bigger than -4. Are we including the point x equals -4? Yeah, it's a solid circle, so we want x to be greater than or equal to -4. And then now we have our whole equation.